Hello, my name is Hajime Suyama from Mitsubishi Electric. I'm an industrial IoT evangelist, and today, as part of the latest industry IoT trends for everybody, I'd like to talk about edge computing in manufacturing. Everybody talks about IoT, Industry 4.0, and here are some of the keywords that they come across, like big data, deep learning, machine learning, artificial intelligence, data scientists, analytics. But there's something you need to remember or don't forget, is that you have to do something in order to get to this phase, which is you have to collect data. You can have all the best technology in the world, but if you don't have the data to send to these systems, you're not going to get anything. So the first step for everybody is to collect data. And it's not just about gathering data, gathering all the data you want, because we have the smartest computers in the world right now, but if you just send these numbers, they're not going to understand anything. Data is, they say, just numbers without context. So you have to do an extra work, and it's what we call changing data into information. All of these numbers have meanings, like RPM, the date it was done, it's a weight figure. And you also have to kind of connect the data, saying, well, it's what everybody calls timestamping. This data was created at this time, using this machine when we were processing this part. If you don't connect all these bits and pieces together, the computer won't be able to understand it. And that's why this initial processing of the data is very important. After you've done this initial processing, changing data into information, then you will be able to go to the data analytics world and the Kaizen world using artificial intelligence. Of course, there's a lot of data lying around in your factory. You don't have to put all these sensors around. There's also already a lot of data in your PLCs, in your robots, in your machinery, and also in your IT systems. So the first step is connecting these data and putting them into one place. A lot of people say maybe the first step is let's just send all the data up to the cloud. But this is going to cause you two problems. Can you really handle all the data you're gathering? A lot of people forget that data is a cost. So a lot of IT companies, a lot of communication companies will charge you on how much data you're sending up to your IT systems and the cloud. So the more data you send, the more expensive your IT bill is going to become. So actually, throwing away data is a very, very important part of constructing IoT systems. The other aspect is the more data you collect, the more time you're going to spend doing analytics and processing the data. Imagine you have one sheet of report and you have 100 sheets of report. Which is easier to do analytics and do your studying? Of course, it's this one report. So in order to make your investigation and analytics time better, it's very, very important to throw away as much data as you can. And that's why I'm saying that this kind of initial phase where you process the data is very, very important when you approach IoT. You use networks when you collect data, but I'm going to tell you a story, and I'm going to use this example of a pipe in water because they say the data flowing through a network is very, very similar to water flowing through a pipe. Let's look at this picture over here. So rain is coming, you're gathering through the pipe, and it flows through it. As you see here, the problem is that because the pipe is very, very thin over here, it's clogging up, and you're also losing some water because there's not just enough capacity. The pipe is too thin. This happens a lot in the data and network world. They want to process the data through the networks in the system, but because the network is too slow or the broadband is too narrow, they're not be able to push all the data through the network. And what happens is actually all the data you are gathering overflows and you lose data. So that's why when you construct data networks and systems, it's very, very important to have a wide broadband and fast network in order to process the data that you're handling. Remember that you're going to use more and more data in the future because you want to collect more data, you want to collect more sensor data, and you want to collect more quality data. In order to process that, a fast network is essential. Okay, does your data let you see the whole picture? When I do this talking about, collecting data and having a very fast network, some people say that, okay, why don't I just stop the frequency that I'm collecting data? Maybe I was collecting data every second. Maybe it's enough if I collect data every 5 seconds. That way I don't have to have a fast network, because the data that I'm gathering is very limited. So this is an example. So let's say that, okay, there's a woman running through, but we're only going to capture data that's running through the network every 5 seconds. And the other 5 seconds, okay, let's just not look at it, let's not gather the data. It might work, but in this case, let's see what happened. So in the previous slide, everything looked normal. But in reality, during the 5 seconds that we were not looking, she fell down and she was happy. So we missed the part that she was falling down because we were only monitoring every 5 seconds. This is a big issue in manufacturing because the kind of predictive maintenance trends that you see, a sudden spike in electricity or electrical current, happens at split seconds. And it doesn't happen all the time, constantly. Sometimes happens only 2 or 3 times a day. But if you're not monitoring every second, you might miss that data. And that's why it's so important to gather precise data frequently when you're looking at the manufacturing floor. I mean, the IT world, when you look at, search engines and, normal activity data on PC, maybe it's okay that you only collect data every second or every minute. But we're looking at the manufacturing world when we're doing processing and we're moving machines at the millisec and sometimes even the nanosec level. In that case, to have precise data is very, very important. And that's why it's really a mistake to just do periodic collection of data. You should have the capability in your network to accumulate all this data and be able to process it. And that's why we talk about edge computing. When I talk about edge computing, edge is of course the edge of things, which means that we need something on the edge of the factory automation, the OT part, and at the edge of the IT system and cloud part in the middle to help us with this initial processing of the data. And it has 4 main characteristics that helps us use effectively IoT in manufacturing. The first 2 steps actually is the filtering and changing data into the information phase, what we call initial processing of the data. So if you have a computer near the factory floor, then you can use this edge computer to throw away the data you don't want to need, and the cloud won't need because it has nothing to do with the analytics you are doing. The other thing is you can, for instance, connect the data, the relevance to the other data, and send it with extra information so it's easier to process in the cloud. The third good aspect of edge computing is a timely reaction you can do to the factory floor. When something happens on a robot or a machine, you don't have time to ask the cloud and say, okay, what should I do? Or is this the correct quality data that I should be getting? Everything is happening, as I said, in split seconds. That's why if you can do some data analysis or computing near the factory floor, you can immediately, when you see that signal or bad trend, stop the machine. The fourth part is system resilience, and meaning, also security. There's a lot of companies that feel afraid of using the cloud because of the various security issues they may have. In that case, you can separate the factory automation and the analytics side and make it in two parts. So we say, okay, let's do the analytics in the cloud, and let's just send the data models or findings that we have and put it in an edge computer. That way, you're not constantly connected to the cloud, and you can have a secure factory automation network when you're running operations. It's also, imagine if you're connecting everything to the cloud and running your system based on the cloud, what happens if the cloud goes down? Your entire network stops and your entire factory stops. And that's something that still a lot of people don't like. So it adds a kind of extra layer of protection for these kind of issues as well. When we talk about edge computing, it's not that we're against cloud computing. We think there's a place for cloud computing, and we think there's a place of edge computing. I usually use this example saying that cloud computing is like a coach, and edge computing is like a player in sports. When we say this, is cloud computing is a place where you develop knowledge, and edge computing is where you put that knowledge into action. The cloud is better when you develop knowledge. You have high computing power, you can handle a lot of information, so it's suitable for doing that. But when you talk about execution, it's better to be near where the action is happening. For example, in baseball, you're teaching your batters how to hit curveballs and how to hit forkballs, and there's a certain way to hit the forkball. You should hit it before it starts dropping, or if it's a curveball, you should wait to the last minute before hitting it, something like that. But in the real game, you don't have time for the coach to yell, okay, a forkball is coming, then you should hit it, swing. You have no time for the batter to react and process that information, because the minute, the second that it's a forkball and you're shouting something, probably the ball is already in the catcher's mitt. So the edge computing, or the player, has to be able to process that information that he has learned before and execute it by himself. And that's how a factory runs, I think. You can have all these findings and from past experiences, and you accumulate them, and then you teach it to the actual machine, saying, okay, if this pattern comes, then stop the machine. It's a bad part. Or the machine is breaking. These are trends that a machine is breaking, so stop the machine when that happens. So I think the cloud is, as I said, developing knowledge, but execution has to be done at the edge computing side, because we're talking about split-second reactions. Catching the right moment is very critical, and that's why edge computing is so important. We're talking about these kind of wave signals that are going through the factory, but these are going through the factory in milliseconds. So you have no time communicating to the cloud and wait for an answer. The minute something wrong happens, you have to stop the machine to secure your quality. And that's why edge computing is very, very important. There's one more issue about collecting data on the factory floor, and I'd like to talk about how difficult it is to collect data and send it to the right system. There are a lot of interesting house devices out in the world, like these kind of smart watches where you can take your pulse, blood pressure, and for instance, scales where you weigh yourself. It's very convenient because if you go to your phone or you go to your iPad, for instance, you can see exactly what the trends are of the last week. Last week was Christmas. Oh, I'm gaining weight, so I should be a little more careful. It's good But I think you have your favorite device, for instance. I prefer a company A smart band, but I like companies B blood pressure. The problem is that all these clouds are different depending on the company you use. So what the issue is, if you want to see your total health score, what my blood pressure is, how was my pulse right now, and how was my weight, it's very, very difficult to combine these systems and timestamp and collect the data and do analytics on it. This is exactly what happens on the factory floor. You have different robots, you have different CNCs, you have different production systems. So just collecting this data is a real mess and takes a lot of time. And on top of that, you have various IT systems. You have ERP systems, you have MES systems, you have SCM systems, sometimes made by yourself and sometimes made by different companies. So it's a real disaster if you want to connect all these systems to see your total IoT score and do Industry 4.0. I've been involved in a lot of projects where we're trying to collect the data and put them in one place, but this takes probably about 80% of the time of the IoT project. You only spend 20% of the time doing analytics or doing visualization. The rest of 80% is connecting the data together and also verifying if the right data is in the right place. But this is life. You're never going to have the perfect factory with only one system, only one IT system, only one factory automation vendor, and only one robot manufacturer. I'm sure all of your factories have mixes. You have also issues with legacy systems and also different data storages and formats. And in the future, you're going to face the possibility of various cloud environments as well. And when doing these kind of IoT products with our customers, we also felt the pain of the customer that, he wants to connect the data and collect the data and put it in one place, but it's actually a mess and it takes a lot of time. I think in the future, there's always also not going to be one IT company and one factory automation company or OT company. There's still going to be different robots, there's going to be different PLCs, and there's going to be different clouds and different IT systems there. But in order to ensure that the end user, the final manufacturing, can collect data and put it to use, we felt that there was the need to collaborate with other companies, even if they were competitors, in order to make the end user happy and be able to continue on his IoT journey. And that was the idea of cooperating with other companies on the edge computing layer. And that was the total reason that we shook hands together with all these famous IT companies and OT companies to form the EdgeCross Consortium to kind of make a place where we can collaborate together in order to connect data, making connecting data easier and more useful to use in manufacturing. It's getting a lot of traction, and right now we have more than 330 plus members joining this EdgeCross computing community. There are already a lot of material talking about EdgeCross and what it does, so if you are more interested, please go to the EdgeCross Consortium homepages or YouTube to see the detailed explanation. But it's basically a software platform, making it easier to move data from the factory automation to the IT systems and edge layer to make it more easy to process. Okay, I hope you got a feeling about edge computing, why it's necessary for the manufacturing. It's necessary to change data into information and to react quickly to what happens on the factory floor. And you have to please think in the future about how you're sending the right data to the right system. And maybe EdgeCross will become a very, very useful tool to do that. I think that's all for my presentation today. Thank you for hearing, and see you again.